Let us look at the determinant of matrices and Cramers rule. We want to see how you form the determinant and how Cramers rule, how you form Cramers rule. So suppose we have two general pair of simultaneous equations in two unknowns. So we have a x plus by equals what now? P. And we have cx plus dy equals, say, q. Alright? Now, let us in fact write p and q in a different color. pq. Alright, good. Now, here, let us multiply. Say, we multiply, or let's call this equation 1 and this equation 2. We multiply equation 1 by d and equation 2 by b because we want to eliminate y and find x. Alright? So, equation 2 times b. We have bcx, so it's bcx plus then bdy equals bq. So we have bq. Alright, good. Then we have equation 1 times d. Let's multiply equation 1 by d and see what we have. D times a, and of course it requires that you remember how to solve pair of simultaneous equations using elimination method, right? So we have d times ax. So let us call this a dx plus then d times by. We have bdy. bdy equals, then we have d times p. So we have dp. Okay, good. Now, how do we eliminate y? We're going to subtract them. You notice this is bdy and this is bdy. So when you say, for example, equation, let's call this equation 3 and this equation 4. We're going to have equation 3 minus equation 4 and see what would happen in that case. Equation 3, we're going to have these subtracted, bcx minus adx, then bdy minus bdy, that is gone, that's 0, equals so we have bq minus dp. Alright, now what is x? X outside the bracket, we have bc minus ad equals bq minus dp. Let's just put it in the same color here. Got a bit tired of switching colors. Alright, so now x is equal to bq minus pd, kind of sounds easier to call instead of dp, pd over bc minus ad. Now let us multiply both top and bottom by -1, both the numerator and denominator. This would form PD minus BQ over AD minus BC. Alright? Now, what would X be? I mean Y. Suppose you say we eliminate X to find Y. How do we do that? Let's multiply. Alright, let's get rid of some of these things here and draw a line and do the work over this side. Let's multiply equation 1 EQ1 by C. What do we get? It's going to be ACX plus BCY equal PC. So you have ACX plus BCY equal P times C. And then equation 2 by A. What would happen? If we multiply equation 2 by A, we have ACX plus ADY equal AQ. See that? So it's ACX plus ADY equal AQ. Alright, so let's work with this and see how we figure this one out. If we subtract them, let's call this equation, we had equation 3 and 4 already, equation 5 and equation 6, and we say equation 5 minus equation 6. So we're going to have this minus this. ACX minus ACX, that's 0. X is gone, eliminated, right? And we have BCY minus ADY. So BCY minus ADY equal PC minus AQ. So PC minus AQ. So Y outside the bracket, we have BC minus AD, see that, equal PC minus AQ. Now, we're going to say Y is equal to, it would be PC minus AQ over BC minus AD. Let's now multiply both top and bottom by -1. What you would have is AQ minus PC over AD minus BC. Alright? Now, here, we see the AD minus BC here and AD minus BC here, which will be the negative of BC minus AD. So remember, AD minus BC, that's the determinant of the matrix, right? That's the determinant. So the thing is that when it comes to the AD minus BC, if you have A, B, C, D, if you remember, it's AD, so AD minus BC, AD minus BC, right? So that's the determinant of this. Now, here, let's write PD minus BQ as a determinant as well. So X would be, so it would be PD minus BQ. No, that would be over AD minus BC. And the y over here, let's write them closer. Could write the y over here. We're going to write them down and then fix them up later on. We have AQ minus PC. That's AQ. The A and the Q kind of look alike. AQ minus PC over, and we have the same AD minus BC. So it's A, B, C, D. Alright. Now, let's fix them up to make them look like Cramer's rule. Here, when we have these matrices, with Cramer's rule, we'd have P, Q. X, to find X, we would ignore the A and C. We'd have PQ first, minus P up top, Q under. So we'd have P up top and Q under. Let's rewrite these in the same color, by the way. P and Q. So it would be P, Q, right? So you replace the first column with P and Q. All right, B and D there. B and D. See that? And then for Y, let's write the P and Q back in red. You have P, Q, write those back in red, and the other things are in black. And then you would write the P and Q second, but the X term, the X coefficient AC would be here, A and C. Let's write the A properly. Oh my, I want it in black. A and C. Alright? So, here now. This is how Cramer's rule is formed. In fact, what I'm going to do is erase some of these workings and put back, copy and put the information I have closer to the original equations. Alright? Alright, so here, let's put this closer up here and study the pattern. So what we have in Cramer's rule, X equals, you're going to write the numbers first. Y equals, you write the numbers second. Alright? For the numerator, determinants. To find X, you're going to write the coefficients of Y, which is BD, second, BD. So you have the numbers PQ, and then the coefficients of Y, BD, over ABCD, the determinant ABCD. Y, for Y now, it is column 2 that you're going to replace with the numbers here. And you write the coefficients of X, AC, over A, B, C, D. Alright? So, that's how Cramer's rule come about, using the general equations here. And we see the very important AD minus BC, which is called the determinants of ABCD.